Hello again. We are going to be talking about solving quadratic equations and the different ways that you can do that. The method we're going to be talking about today is solving those quadratic equations by graphing them. All right, so let's get started. When we do solve something by graphing, here's what we mean by that. We're just going to look at where the graph crosses the x-axis. Okay, so why is that? Well, all the points that are on the x-axis have the same y-coordinate because you really don't have to go up or down to get to any of those points. So what that means is the y-coordinate for all of those points is 0. All right, so in terms of quadratics, here we've got a quadratic, and I'm showing where it crosses the x-axis. So that's the function y equals ax squared plus bx plus c. That format is the format for all quadratic functions. So if we're solving ax squared plus bx plus c equals 0, then by the transitive property, what we're basically solving is when is that y on the left equal to the 0 that's on the right. All right, so that's why we're looking at the x-axis when we're trying to figure out when a quadratic is equal to 0. Okay, so there's three things that can happen when you try to do this. The first is that you'll have two solutions. In other words, the quadratic function will cross the x-axis twice. So as an example, let's look at x squared minus 2x minus 15 equals 0. Well, what I'm going to do is I'm going to graph y equals x squared minus 2x minus 15. And there you see the graph. And what I'm going to do is I'm going to look at where it crosses the x-axis. And it crosses at these two places right here, at x equals -3 and x equals +5. All right, so those must be the solutions to the quadratic equation that I was given. And just to show you that they are indeed the solutions, I'm going to plug each of them in for x into the original equation and see that the left-hand side does end up equaling 0, which is on the right-hand side. So if I replace every x with -3, then I get -3 squared minus 2 times -3 minus 15. And that ends up being 9 plus 6 minus 15, all of which is equal to 0. So x equals -3 does in fact work. When you plug it in, you get 0. And you get the left side equal to the right side. Now if I check with x equals 5, I plug it in and I get 5 squared minus 2 times 5 minus 15, and that ends up being 25 minus 10 minus 15, and that's also equal to 0. So both of those solutions actually work, and those are the two solutions to my quadratic equation. All right, the next situation that could possibly happen is that you only have one solution. Okay, so for example, we are going to solve x squared minus 8x plus 16 equals 0. And I'm going to start the same way I started the other one, and that's by graphing y equals the expression that's on the left. Y equals x squared minus 8x plus 16, and that's what the graph looks like right there. And as you can tell, it only crosses the x-axis in one place, right there, at x equals 4. So that is really the only solution to the original equation that I was given. All right, and I can check that, again, just like I checked the other solutions by plugging it in. When I plug x equals 4 into the original quadratic equation, I get 4 squared minus 8 times 4 plus 16. And that ends up being 16 minus 32 plus 16, which of course is equal to 0. Okay, so that's the only solution that would work. And the last thing that could possibly happen is that there's no solution. All right, so if I solve x squared plus 3x plus 4 equals 0, what I'm going to do is I'm going to graph that, and I'm going to look at where it crosses the x-axis. Okay, well, it doesn't cross the x-axis, so what that means is there's no solution to this quadratic equation. All right, and that's the last thing that could possibly happen. So those are the three situations that could occur. They also occur with the other strategies that we're going to talk about for solving quadratic equations, but just to give you an idea of what the pictures of those three situations look like, that will help you in future lessons. So if you have any questions, please let me know, and I will see you tomorrow.